What's up, guys? Welcome back. To use filtering effectively, you have to know how to select the observations that you want when using comparison operators. R provides support for the standard comparison operators. So we have greater than or equal to, less than or equal to, and we have not equal to and equal to, right? Which is the logical equal to. And like I said in the last video, we got to make sure that we're going to be using two equals signs when we want to do a logical equals, because if we just use one, R is going to think that we're doing an assignment, which is not what we're trying to do, and we will either end up with incorrect output or we're going to end up with an error. So what's also important to note with using the logical equals to sign is that when using floating point numbers, we'll get some errors that are unexpected. So if I want to go and find the square root of 2 squared, we know the answer would be 2. But if I run this code, R gives me the output of false. So this is because computers use finite precision arithmetic. So what happens here is that the square root of 2 squared is actually an approximation, and it's not actually stored as 2. So in order to go and rectify that, we should use dplyr's near function to be able to use the same comparison that we want, but get the desired answer also. So if we put in square root of 2 and then we square it, and then we want to see if it's equal to 2, which it is, we get the correct answer, which is true. So why is this working? If we look in the documentation for the near function, we see that the near function is a safe way for comparing if two vectors, or in our case, two elements of floating point numbers, are pairwise equal. This is safer than using the logical equal because it has a built-in tolerance. So what's happening over here is that we have a built-in tolerance with having a small amount of error being accounted for. Now, going back to the filter argument, the filter function, for multiple arguments with filter, everything is combined with and. So what happens over here, each argument in the filter function is combined together with an and. So if I were to go and write month being equal to November and the month being equal to December, I get an empty table because I have no data whose month is both November and December. If I want to go and have my data filtered only to months from November and December, I need to be using the logical OR, which is a vertical slash. So running that, I get my desired filtered data set. Now, if we want to use other Boolean operators, R has the not operator, and if we're going to be using and outside of the filter setting, we can use the ampersand symbol. Now, another way which would be good for shortening our code with using OR statements would be using the in operator. So let's say I want to filter my data set for flights from months of September, November, and December. So I can either write it as month being equal to September, month being equal to November, and month being equal to December. And that's quite long and kind of hard to read also. But if I want to go and shorten it, I can actually go and add a special operator over here where I first write 2 percentage signs and I put in the middle in. And I write an R vector and I put the months that I want to filter my data set on. So I put September, November, and December. And if I filter it, I get my desired output by running the function. So sometimes we can simplify complicated subsetting by remembering De Morgan's law. So if I want to go and look at, for example, flights that have had only arrival delays and departure delays that haven't been more than 2 hours. So just to go and clarify that, I'll say it again. I want to only have flights that have not had delays either from their departure or from their arrival being more than 2 hours. So what I can first do is that I could filter my data set by writing the arrival delay being greater than 2 hours, right? In this data set, it's in terms of minutes, so I put down 120 minutes, or my delay time, right, being the departure delay being greater than 2 hours. So now, because I want to have my data having only arrival delays and departure delays that are less than that, I can put the not symbol in front of it after wrapping it in brackets, and I have my data filtered. But this is a little bit hard to go and look at. If I remember De Morgan's law, you could easily go and switch this by just flipping the inequalities, getting rid of the not sign, and changing our or operator with an and operator, right? It's a little bit easier to go and explain it if I just write it out here. So if I have, not X and Y is the same thing as saying X or Y, right? As not X or Y. And also, if I were to have not X or Y, this is the same thing as saying not X and not Y. So with that in mind, we have code which is easier to read by using De Morgan's law. So this is all for now. And in the next video, we're going to talk about missing values. Thanks so much for watching. And if you enjoy content like this, be sure to subscribe and not miss an update. Thanks for watching.